Hello ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be going over how to draw and name simple alkenes and alkynes. So make sure that you're following along in your note packets, and then if you have any questions, you ask me tomorrow. So the rules that we covered for naming branched alkanes, they also apply to alkenes and alkynes. Alright, so what are those rules? Well, we already went through them. So make sure that if you have some problems with naming branched alkanes, that you look over those, because we're not really going to be reviewing them very much. The rules, though, are almost exactly the same. All I have to do is change my endings. So instead of ending in ane, like, sort of, I don't know, let's see, like 3-ethyl heptane or something like that, now all of my endings end in ene if there is a double bond present, or ine if there is a triple bond present. So in these pictures here, my base system stays exactly the same. So as you can see, this is a 5-carbon chain, and it contains a double bond. So that would be pentene. Okay, again, that's not the name of that compound, but that would give me the basis for the name of my compound. The same way that I have to find my longest carbon chain and everything. Okay, so right here I have a triple bond, and since there are 6 carbons in that chain, that would be hexyne. So really just change the ending depending on whether there's a double or a triple bond. That's like pretty much the first big step. Second step, when I'm choosing my longest carbon chain, it must pass through the double or triple bond. So double and triple bonds are given priority. So for example, take a look at both of these. These are really good examples, actually. Okay, so take a look. If I wanted to make a longest carbon chain, there are a couple of ways I could try to do that. All right, I could do it, sort of, by doing, this, or doing this, or going around here, or going up here. There are a couple of different ways of drawing it, but doing it this way, so if I follow my very first circle and I go down here, that only has 1, 2, 3, 4, 5 carbons in it, though. Now, this one, though, if I were to go around, 1, 2, 3, 4, 5, this one has 6, so wouldn't this guy be better since it's the longest carbon chain? But it has to pass through the double or triple bond. Doing this does not pass through this double bond. So I can't have this as a possible chain for my compound. It's just not possible. And the reason why is because it does not contain, like it says here, the double bond. So since it doesn't contain the double bond, it's not a possible structure. So even though it was possible to get 6 carbons in a row here, because it didn't pass through the double bond, I can't choose that one. It's not a possible carbon chain. In fact, this right here is the best carbon chain because I get 5 in a row. If I would have done this, I would have only gotten 4 in a row. So doing this gives me my biggest carbon chain. Next up, I have to identify where my double or triple bond is. So that means I must put a number of where that carbon is, where the bond starts. So in other words, take a look at this guy right here. This is what we call 2-hexene. Why 2-hexene? Because I have to first of all have, sort of like a double bond somewhere if it ends in ene, and also my numbering, as you can see, goes like this: 1, 2, 3, 4, 5, 6. So at carbon 2, that's where my double bond starts. That's what this 2 represents. Why didn't we start numbering the opposite way? Because then I wouldn't have a double bond until carbon 1, 2, 3, 4. So carbon 4 would have this. If I were numbering it the opposite direction. So remember, I want to hit my double bond as quickly as possible, and I want to make sure that I tell where that double bond is. Another thing that won't really be coming up, but if there are 2 double bonds, then we often call those dienes or trienes. And so again, I'm just telling you this as like a little fact, but you won't really be seeing it. So the names of these guys would be 1,4-pentadiene, because I have pentane as my base here, because there are only 5 things, but I have, 1 double bond after carbon 1, and I have another bond after carbon 4. Over here, this is 1,3-pentadiene, so I have right here a double bond, right here a double bond. Again, you won't really be seeing these guys, but it's still a good idea just in case, in the future you ever take another chemistry class. That's what a diene and a triene are, though. That's if you have double bonds, 2 of them, or 3 of them. All right, so we're going to name the following compound. So let's take a look. I need to number it. So I could number it a couple of ways. I could go this way, or this way, or this way, this way, that way, that way. There are a lot of ways of kind of numbering this one. But remember, I want the longest carbon chain, but it has to pass through the double or the triple bond. Okay? So there's really only one way of getting this to work. 1, 2, 3, 4, 5, 6, 7. And then I could either have 8 up here, or I could have 8 over here. It'll give me the same result, so I'm just going to leave it like this. So what is my base for this? I have 8, so that's oct, but I have a triple bond, so that means that it's octyne, like this. Okay? I also have a side group up here, and that's at carbon 7, and that is a methyl group. Okay? One of the very first things I have to do whenever I'm dealing with a double or triple bond is tell me where this bond is. It's at carbon 2, so this would automatically be 2-octyne. And then I have to point out that I have a 7-methyl group. I have a methyl group at carbon 7. So that would be 7-methyl-2-octyne. That's the way I would name that. I'm going to be drawing the line structures for all of these because even though line structures aren't exactly the most useful, they're sometimes kind of cool. So I wanted to kind of draw a line structure for how this would look. So again, oct means 8, so I have 8 carbons. So 1, 2, 3, 4, 5, 6, 7, and then 8. At carbon 7, I have a methyl group, so that would look like this. At carbon 2, I have a triple bond, so it would look like this. So that would be our line structure for 7-methyl-2-octyne, and I just think it looks kind of cool. So draw that also, please. Let's try this one. This is a good one. So name the following. So I need to have the longest carbon chain, but it has to go through the double bond. So here's the big thing. There are ways of doing this. So I could do this, I could do this, I could do that, I could do that. But if I do either one of these, it doesn't pass through the double bond. So these are absolutely, positively not real compounds. I can't start numbering going like this somewhere. Has to travel through. So how can I number this? There's actually only one way of numbering this one. 1, 2, 3, 4, 5, 6, 7. Okay, so 7 is hept, and I have a double bond, so that would be heptene. Now I have to worry about all of my side chains and everything. I have this side chain. We haven't seen this one very often. That is a propyl group, and that's at carbon 2. Okay, and then I have a double bond, like I said, and that's at carbon 1, actually. That's where that starts. So I have 1 heptene, because that's where my double bond exists, and so I'd put 2 propyl in front of it. 2 propyl, 1 heptene. That would be the name of this compound. Now again, I kind of want to draw the line structures for some of these, because again, line structures, even though they're weird, they're kind of cool looking sometimes. And so I have heptene, so I have to draw 1, 2, 3, 4, 5, 6, 7, and there's heptene. Now I have a double bond after the first one, so that would look just like this. So I have a double bond. And then at carbon 2, I have a propyl group, so that would look like this. 1, 2, 3. That's a propyl group. That's one possible line structure for this compound, and I just think it looks cool, so that's why I kind of wanted to draw that one out. So let's try to name this guy. Okay, I need to number my carbons, and I need to want to make sure I have my longest carbon chain that passes through my double bond in this situation. So I could do this, I could do this, I could do this, I could do that, I could go up. There are a lot of ways of kind of doing this again, but really only one of them will work. Okay, so here's 1, 1, 2, 3, and then 4 could either be actually it could be any one of these methyl groups, and it doesn't matter. So I'm just going to go across, and now let me circle. Again, I got a double bond here. I've got my side groups. So I've got a methyl group over here. I've got a methyl group over here, and I have my double bond at carbon 1. So again, I only have 4 carbons in a row, so that would be bute. And since it's a double bond, that means I have butene, like this. And my double bond appears after carbon 1, so it's 1-butene. And I have 2 methyl groups at carbon 3, so that would be 3,3-dimethyl, 1-butene. Okay, so again, that's the way that this general process works. So I have my base system, okay? Then I have where that double bond would be. then I have all of my side chains taken care of. Now I wanted to draw the line structure for this because this one looks crazy. In fact, I think I'm going to need a lot more room, so I'm probably going to actually have to erase this entire thing. Just make sure you got that down and you understand kind of where that comes from. But this is what that would look like. So again, I have butene, so 1, 2, 3, 4. I have a double bond at carbon 1, and then at carbon 3 I have 2 methyl groups, so that would be the best way of probably doing that. In fact, actually that looks a little strange. Let me make sure I'm getting my bond correctly. There you go. That's what it would look like. That's one possible way of drawing the line structure for this, and I don't know, it just looked kind of weird, so I wanted to make sure we drew that one out. Alright, let's try this one. This is another good one. So I want to have my longest carbon chain that passes through my double bond, so I could go this way, I could go that way, I could go this way. A lot of ways of doing this, but again, it has to pass through my double bond as soon as possible. So that means that technically there's only one way of drawing this, only this way. 1, 2, 3, and 4. Okay, that's the only way I could do this and have it work. So again, I have a methyl group, I have a double bond. My methyl group is at carbon 2. My double bond is right here. So again, I have butene as my base. It happened. The double bond occurs at carbon 1, and at carbon 2 I have a methyl group. So I have 2 methyl, 1 butene. So how would I draw that? Alright, let's draw my line structure. So 1, 2, 3, 4. Carbon 1 has my double bond, and then carbon 2 has a methyl group. Up like that. That would be my line structure for this. So, what do I need to remember? Still remember, if I'm trying to draw these things, that carbon still wants to have 4 things. So I could have the following as a double bond, or if it's at the end of something, I could have this. Because notice, I have 2 bonds, so right here, I have 2 bonds, I have a hydrogen, I have another bond. That is 4 bonds. Over here, I have 2 hydrogens, that's 2. I have a double bond, that is 2 bonds. I could have something like this for a triple bond. Okay, why? Because again, if I take a look at this, I have carbon and hydrogen, that's 1 bond, and then I have triple bond, so that's already 4. Or I could have this, where now I have, carbon with 3 and then carbon attaching to something else. But these are the ways that we kind of deal with double or triple bonds. So start by drawing the longest carbon chain using, again, only carbons. You only want to use carbons. This looks much nicer, actually. So here's a beautiful image of what the possibilities could look like. Then, after you have your longest carbon chain using only carbons, then start adding your double and triple bonds and your side groups. Finally, add in all of your remaining hydrogens. Make sure that you have the proper amount of hydrogens around something. Remember, carbon can only have 4 things, so you're limited. You can't have anything with 5 bonds.